So when we look at, the acceleration of the network lifecycle with automation, things have changed drastically over time, right? We hear about Industry 4.0, the shift of network services and network functions towards cloud is natural in today's day and age, right? With 5G being rolled out, there's a growing number of components and functions that follow the network lifecycle process, right? The network service lifecycle process, which is starting from the service onboarding, putting your virtualized network functions, test them for interoperability, make sure that the services are validated, and then roll them out into production, which are then actively monitored to make sure these services are delivering the quality and the performance that they stand for, right? So thanks, and how is that being made sure today is thanks to the advancements in automation with the CI process, which is continuous integration and continuous deployment. Gone are the days when network rollouts used to take months. Now it has trickled down to more like days with rapid deployments and advancements in the automation, earlier in that automation chain. But there are certain nuances to that because, as I mentioned, that there are growing number of components now. 5G is an even more complex architecture. So really, it's about, the ability to deliver those services has definitely changed, but the process to guarantee the performance quality has to also catch up. If we look at that process stack, it starts from the preparation part, which is your test preparation, your data preparation, your making sure your network functions across all different domains are plugged in for interoperability. Then comes your execution stack, and then really on top of that is majority of the time being spent, which is 60% of that life cycle, is spent on the troubleshooting portion alone, right? It takes hours and hours together to really find the needle in the haystack as to where a root cause is in the network, so I can remediate on top of that, right? So there is a definite need to accelerate the troubleshooting process, primarily because when we talk about telco networks, they're really complex. There are a lot of data points that need to be analyzed in order to be able to remediate. Why PCAPs for network troubleshooting, right? There are literally tons of data sets one can look at, right? You can look at network function logs, you can look at transport layer logs, you can look at your performance management, fault management, change management processes. You can look at Jaeger logs. There's literally so many data sources you can look at, but why PCAPs specifically for network troubleshooting? First point is because PCAPs are literally the only raw and vendor agnostic sort of standard data capture. They're mainly driven by standards, and the structured format allows for decoding binary network data, right? Which means they follow a standard suite of protocols. As I talked about some of them in my previous webinars, 5G is governed by a standard set of protocols. 4G is also governed by a standard suite of protocols. So this is where it can provide a lot of visibility into the problem that's being caused in the network, right? So really that why piece as to why there are anomalies in the network, why are catastrophic failures happening, are revealed by packet capture. Agility, which is B-Yond's AI and machine learning powered tool for packet capture data analysis that specifically hones in with the mission of service acceleration in that network evolution lifecycle. So what is the target state with agility root cause analysis? It looks at 100% end-to-end automation of the lifecycle, right? Either testing, active testing in labs, or proactive monitoring in production networks, be it either, right? Which essentially increases the RCA coverage or your root cause coverage by 10x, which essentially brings down your cost reductions up to 90%. Also, in turn, allowing you to scale testing and perform analysis that much faster, right? So you're looking at the target state at network data curation part is automated, and then your analysis and troubleshooting portions are also automated. And the way we do that is provide pre-trained machine learning models for test validation. And these are built for a variety of services like across both domains, 4G and 5G, for connectivity, voice, mobility, SMS, data services, and many other services like special services like 911 as well. The PCAP is essentially like a black box where you have to go through packet by packet, try to correlate multiple protocols together to be able to deduce that one single frame or IE where potentially the issue is, or even identify the node that's causing the issue, right? So that's where a lot of those core tasks are automated by agility. Now let me dive into the demo. So as I said, there are multiple options. I can always start a new analysis and upload PCAPs manually through the UI. But of course, as I said, the end-to-end automated process, hands-off, headless persona is also available, which can be integrated using APIs. Now, I already have some files that are uploaded here, and today, for the purpose of this demo, I'm going to be taking some examples of EPS fallback, essentially because it's a hairy call flow. It involves both domains, and it is a classic use case for troubleshooting purposes in the journey of evolving from 4G to 5G, right? And Agility can also accept zip files, which means I could have hundreds and thousands of PCAPs bundled into one zip file, and I can feed that to Agility, where I can have the complete analysis available for all of those PCAPs, right? Now, what happens once I upload those different files, right? The first view that I mentioned is the high-level summary view that Agility provides. So as and when data keeps coming in real time, the analysis is also available in real time as seen here, right? So that essentially covers the quality and the performance part of it. As I was mentioning, it is more of a proactive approach than a reactive approach. I, of course, have the EPS fallback flows already executed here. And for the purpose of the demo, I'll actually dive and focus into how Agility breaks down the PCAPs and the different kinds of insights that it provides. The first one, as I was mentioning, is the high-level summary. So it looks at, services that are detected, which means while I'm processing those PCAPs, I can actually apply a service model against that PCAP, which means for all EPS fallback PCAPs, I can apply a model that looks and evaluates all the end-to-end EPS fallback messages, right? And that's what it's telling me. It's telling me that there was one service related to 5GSA mobility or EPS fallback detected. It also detected about 28 network functions. Now, this is where I will stress on the fact that dynamic topology mapping is absolutely crucial in order to swiftly identify which network function is causing the failure instead of having to rely on host IP mapping files. So that's where Agility is providing information on the unique types of network functions that it detected. It is also looking at the various subscribers, and right, because ideally, as I said, a PCAP can be a black box. There could be multiple subscribers for various activities, and it is important to correlate each one of those subscribers for their call flows. And ideally, this is a very time-consuming process, right? Along with that, Agility also provides the total number of call flows detected. A call flow is actually a unique attempt for an EPS fallback. In this case, it can be applicable to Warner, connectivity, data, and many other services, right? Agility provides these 5 different triage validation functions. The first one, as I was mentioning, is a sequence diagram, right? Now, this sequence diagram is an interactive sequence diagram. The first thing is it automatically builds the topology by mapping the IPs which means as you see, each map IP has been mapped to a network function across the 5G domain and across the 4G domain as well. So in this case, I really don't have to rely on a host IP mapping file in order to look at which network function this belongs to, right? And that really eliminates the problem of network functions being virtualized today and IPs being dynamic. In fact, we have seen cases where the same IP can be assigned across originating and terminating nodes. So ideally, I would have to flatten out that topology in order to look at the message exchanges between both domains. The next tab is the level analysis. Let me just collapse this. The next tab is the protocol level analysis. As I was mentioning, in order to be able to troubleshoot packet captures and a call flow, there are multiple protocols that are intertwined, right? In EPS fallback case, there is NGAP, HTTP2, PFCP, GTPv2, diameter, S1AP. There is SIP as well for, of course, your IMS handshakes. There could be multiple other protocols as well, right? Depending on which layer you're troubleshooting at. So that's where Agility actually automatically breaks down the analysis per protocol, which means actually even before that, the first thing that Agility provides is whether this protocol was indeed available in the PCAP or not, right? So for the ones that are not discovered, it could be that the protocol was not captured, or probably the call flow truncated before that protocol could be invoked. Now, for protocols that are indeed invoked in the PCAP, Agility evaluates each one of the sub-procedures for that protocol, right? As I said, EPS fallback will have your 5G connectivity. It will have some mobility management procedures, session management for data, of course, branching out to your internet network. You'll have your IMS specifically for voice. You'll have all your 5G HTTP2 SBI exchanges. And then, of course, you will have your PFCP for packet forwarding, N4 setup, and then you will have GTPv2 for your N26 handover towards LTE, right? So a lot of correlation has to be performed within each protocol and also across multiple protocols to isolate root causes. So that's where Agility is automating that core task of bundling these protocols together. Now, this one was really a signature where there was no response for the create session request, right? We did see that tackled here. And if I were to filter this call flow to show errors, again, I see a lot of failures, cascading failures across multiple network functions. Some of them are in the IMS layer with SIP failures. Some of them are S1AP based. I see a tracking area update, reject. And then, of course, I see GTPv2 based failures as well, right? So this is where it becomes critical to identify that single point of failure where the root causes are occurring, right? So that's where the model is essentially honing in to this one single message. There was no response received for this, right? As you can see, the message cause is also detailed along with remote peer not responding, right? So that's how it is able to accelerate the troubleshooting journey. The third tab is your flow extractions tab, which is similar to what you would see in packet analyzer tools, but this is cutting out all the background noise, not contributing to an EPS fallback call flow, right? There could be a lot of TCP packets may not be of interest. There could be some UDP packets that may not be of interest. So that's where Agility is only filtering those packets of interest that contribute to an EPS fallback call flow. This is where Agility can compute a lot of KPIs from PCAPs, and this is completely customizable. We know that packet captures can provide a lot of information in terms of the times, the time that it is taking for call flows to set up, or look at who's the most talker, who's the most listener. how many retransmissions are happening. All those statistics can be derived, and that's what agility provides. But this is completely customizable depending on the service, right? So for voice, I can look at call setup times and latency, but for data services, maybe latency is more applicable, retransmissions or corruption rates, and these kinds of KPIs are very valuable there. Just in wrapping up and conclusion, we looked at automation for troubleshooting specifically, and the bottlenecks that are there in troubleshooting, because it is a highly manual, labor-intensive process. And automation and machine learning will ensure that the process of quality matches the pace of change that the telco networks are undergoing, right? While simultaneously lowering and accelerating that network service lifecycle. The next thing is applied AI and machine learning can truly help achieve troubleshooting at scale, right? Where we talked about potentially looking at any number of PCAPs that are being captured across the network, either for active testing in labs or proactive monitoring in production networks, and for devices as well, right? And then we also looked at why PCAPs as a data source, because PCAPs are really the single source of truth that reveal anomalies in the network and justify why of a failure, right? There are, of course, other data sets I can always analyze, but really PCAPs gives a great start, right? It's really the tier 3 of troubleshooting that gives me a great start as to where an issue is happening and why is it happening. And of course, talking a little bit about agility, it also introduces service models that automates root cause analysis for classification of call flows using PCAPs as a prime data set. And the advancements in machine learning and Gen AI can actually help provide extensive readability on root causes by integrating with any knowledge base.